Okay, welcome everyone to this session. Now we'll have a talk, introduction to the V language, and this is Erdet Nasufi, and he will present us this project for us.
Yeah, hello everyone. Thanks for coming. Today I'm going to talk about Vlang, V. It's a quite new language. It started in 2019, and it's so it's kind of an introduction. Since it's new, it's not that I have the chance to go more deep into the language, but more a basic and an introduction. I truly believe that it might be beneficial to the DebConf and Debian community. So this is the agenda. I will let you know what is V and how it looks like, some basic and built-in data types, how the statements, expressions, functions, and would look like. Also, I will talk shortly about the custom data types, modules, generics, and the exciting part for me, integration with C and using V as a scripting language. So what is V? Or you can find also as a Vlang. I guess this is from nowadays from Golang and the Lang expression. So Golang is quite a modern language that provides simple, readable, and maintainable code. And it's fast and also safe, but by being fast and safe, it also supports bounds checking, built-in arrays, maps, and strings, which, for example, in C, we have like fast code, but we do not have arrays, maps, and strings as embedded built-in data types. C is safe because it does not allow undefined values, and it's safe from variable shadowing. Also, by default, all arguments, variables, and structure are immutable. Also, it provides a nice and simple error handling mechanisms. It supports generics compared to C, and no global variables, so it's safe from that perspective. Besides, it's no P, but it's quite modular. It supports C interoperability, but without any cost, and it's highly influenced from Golang. So if you know Golang, you can easily go through that. But also some aspects are taken from the Rust. So how Vlang or a V code looks like. So this is a simple example, like a hello world in V. As you can see, the function starts with FM, and the starting function is main, obviously, as with many languages. You can run it without generating a binary, which is like vrun test.v, or you can build a V file by using just V and the file of the source code, and you can run it. Also, it supports translating to C code. So by using v test.v and the -o flag, you would be able to have the C translated version of the V code. By the way, last night, just for curiosity, I compiled the same hello world in Go. And it's not that I'm good with Go, by the way, but I just took that for comparison, and it was like 107 something kilobyte, while in V it's around 18 kilobyte. So how other functions looks like. So unlike C and similar languages to C, where argument starts with data type and the variable name, in V it starts with the name and then the data type. And the return of the function, again, unlike in C, where you have as a starting of the function, here you have at the end of the parentheses of the arguments. V also supports multiple return values. As you can see on the function swap, you have both return types and integer, but you should keep them in a parenthesis. Otherwise, it will fail. A quick practices of coding style in V. All functions, variables, arguments, module names, and almost, despite the custom data types, should be on snake case, while custom data type, structure, names, types, alias should be on Pascal case. Similar to who is familiar with GNU, GDK family of libraries. So as you can see here, we have a quite simple error handling mechanism. On the line number 10, when we return an F64, basically it has a question mark before. I prefer to call it as a questionable return type. This means that it either returns the value or the error. And how you can handle the error, it's simply by using the OR operator. So here, we intentionally triggered the error. So as you can see from the divide function, if the b is equal to 0, it will return an error. And on line number 4, we called it that function and we gave b as 0, which in addition to printing the error, it returns the value 0. And the d will be declared to 0. Yeah, so it's the same with multiple return values, but instead of having question mark for each and every return value, you should put the question mark before the parenthesis of the set of return values. But an interesting thing, as you may notice from the line number 4, you have function D will return 3 values, right? But as you can notice on the line number 4, you get D and there are 2 underscores. This means that V will ignore returning that values. So this helps, for example, if you do not need that value and you assign to a variable, then V will fail because that will trigger that you didn't use that variable. So this will save you from having that error. So as I mentioned at the beginning, another aspect of safety of V is quite simple. It does not support global variables. So this means that you have each and every variable within a scope, and it's quite predictable. So here we have timeout in milliseconds, which is in a global variable, and it will fail. So we added, as you can see on line number 10, we added that on the line within the main scope, and it will be okay. What V supports as a global is only const. So constants will be supported as global values, let's say. V also supports anonymous callbacks and closers. So this is a kind of typical from the books, let's say. You have 2 functions where the prototype is 2 integers and it returns an integer, while the calculate function, as you can see, the third argument is an operation, and the type of that argument is a callback. So it's you put the prototype of the function, which is fn, and 2 arguments and the return type. And then on the line number 10, you have that operator returning the callback. So on line number 14 and 15, we simply give the name of the function which is in match with the function prototype. So similarly to the function callbacks, we have on the line number 6, as you can see, we directly define the function without any name, which is like anonymous function. And another way is V also supports having functions as a variable. So as you can see on line number 10, We have fx, which is a function similar to functions add and multiply, and keeps the same function match. Matches the function prototype. To save us from, let's say, adding too much code, V supports also alias to the function prototype. So instead of having at operation, for example, line number 10, the third argument, instead of putting the fn, both arguments, and the return type, we can simply alias that to math fn, which is math function, and we use that as a type. Similarly, we can use the that type alias to cast a function. For example, on line number 14, we have the function add, and we casted that to add fx, which tells V that explicitly this should be that function prototype. V also supports closures, which means it's an extension of anonymous function, but within the square brackets we give the values that will be inherited from the scope where the function is called from. So here we have fz, which is a variable to function to the following function. But in addition to both arguments a and b, we gave inherit x and c. And on line 11, we call it just fz, right? Yeah, so by default, let's say all variables and arguments are immutable. So as you can see, line number 4, we have timeout in milliseconds as integer. And on line number 5, we tried that to reassign to 1000, but V will fail on that. This will require to set it as a mutable. Yeah, which, for example, this allows us for, as you can see on line number 7, allows us to do that for timeout in microseconds. V also supports multiple declaration and assignments. So here we have, as a mutable, we have year, but immutable the name and mutable location. When we try to reassign as multiple reassignment on the line number 5, we have year and name, but it fails. Despite from the level line 6, which it is okay. The reason I took this example is that you can easily miss if you put the mutable only for year and leave the rest not specified. V will take that only for year, but the rest of variables will remain immutable. So let's go through some basic data types. V supports as basic data types the Boolean. You can see unsigned integers from 8-bit to 64, similar to unsigned integers from 8 to 64. And the thing I like on V is that it has F32 for float and F64 for 16-bit floating points, which is for me like working on embedded platforms and like switching from hardware to hardware. I have always to check the size of the floating point. It also supports void PTR, which stands for void pointer, and this is for convenience and operation with C. Also, it supports built-ins, arrays, strings, and maps, which is quite helpful compared to C. So on the right-hand side, you can see some literals. I took some edge cases, let's say. As you can see, one interesting thing you may notice here is the underscore. So underscore here means just for reading purpose. It has no meaning. Like V will ignore that and will make as a single value. But for hexadecimals, binaries, it's quite helpful. Obviously, on line number 5, you can see that binaries you can put similar to, I think it's C++. Nowadays, you can put directly with the binaries, right? Yeah, so V is quite sensitive on the data type promotion, automatic promotion. So here we have an example where we have A and B. A is an unsigned integer of 16-bit, while B is an integer of 32-bit. If we try to add these two numbers and we assign to A, which is less in size compared to B, which is I32, it will fail. While the same will be okay in line number 8, because as you can see, unsigned integer 16-bit will be promoted to unsigned 32-bit, and then it will be promoted directly to the integer, so the line below. The reason I kept bold and red the int and f62 is because in V, any integer number, if it's not explicitly set to the data type, it will be switched to integer, and the same is for floating point. So it means that floating point default number is f64, and default integer number is data type is integer 32. So arrays, there are two ways of declaring arrays. So the simplest one is by listing the elements within the square brackets. And you can access it, as you can see from line 3, similarly with C, using square brackets. In V, indexing of array start from 1. No, just kidding. It starts from 0, of course. So as you can see on line number 4, despite that we were able to access to second element, we are not able to reassign it to -1. This is because we didn't specify that vector is immutable. So by not specifying it as a mutable, we will not be able to change the values. Compared to the case, the line below, which is array, and we specify that immutable. So this means that we can change the values, but in addition to changing the values, we are able to also, using the push operator, we are able to insert values. I took two examples. One is we pushing the -2, and again we pushing an array. Just to show you that by pushing an array, it will not add an array as an element, but it will extend that array for 3 other elements. And this is simply because V does not support having arrays of different data types. So once you specify the data type of the first element, all other elements will be of that data type. If we go in C, look, if you translate this and check on C, this is basically a data structure, and the array is a void pointer. So this is another example where we use the in operator, because V supports in operator to check if element on the left side is in that array. So as you can see on line number 4, it checks if debconf23 is in debconfs, and it will return true or false, depends from if that element is within array. The other way of declaring arrays is more explicit way, where we specify the type. So it starts with square brackets, and then the T as a data type. The 3 below parameters are optional, and it's capacity, length, and initial value. As you can see on the code below, line number 2, we declared explicitly an array of type integer with capacity of 5 elements and the length is 2. The initial value is -1. So it will return not 5 elements, but it will return 2 elements, despite that V has allocated 5 elements. Here we have another example to show more about the capacity versus the length. So we started an array, call it vector, of 3 elements and the capacity of 3. But if we push, as you can see on line number 4, if we push an element, it will not extend the capacity for 1 element, but it will double it. So it will switch from 3 to 6, while the length remains 4. Similarly, if we continue pushing elements and we we exceed the capacity of 6 elements, it will double it from 6 to 12. V also allows us to reassign a mutable array to an empty array. And the capacity and the length remain 0, while the data type is as per the data type specified at the beginning of the declaration, which is on line number 2. Apparently, V supports multidimensional arrays. So here we have a 2D and 3D array. All it requires is a set of the square brackets. So for 2-dimensional array, it requires 2 sets of square brackets and the data type. The only difference here, as you may notice, is that when it comes to initialize that array, it requires another array of 1 dimension less than the dimension it is specified. So on 3D, when it comes to initialize the 3D array, it initializes another 2D array, and the 2D array initializes another 3D array. While the accessing of the multi-dimensional arrays is similar to C. Here we have, if you want to look more on the built-in functions for arrays, you can check the link here. But I will stop to these two functions, filter and map. And it's not because of these 2 functions, but it's more about this it operator. It operator is a built-in variable in V, which represents the actual element that is processed. So, for example, we filter the array vector, and this is filtered like it bigger than 2 and it lower than 7, which means that it checks each and every element of the array, right? Similar to map, it will come with another array by taking each element of the array and multiplying it by 2. So this is simply done by using it built-in variable. So as I mentioned before, array basically is a void pointer if we dig into C code. And this means that we are not allowed to declare an array by simply assigning it to another array. But why? Because this is considered unsafe for V. And the only way to declare an array based on another array is to use a function clone. And as you can see from the, let's go to the code below. So the only way to declare an array as it is B here to another array is to switch to unsafe mode. So unsafe mode is not necessarily meaning that the code within that scope is unsafe, but this allows us to, gives us more flexibility and less checkings from V. But the difference between cloning and here, like unsafe mode, is that, as you can see from the line 5, number 5, the third element is reassigned to 9. And by comparing C and A array, this means that that element is changed only on array C, but not on array A, which is different from the unsafe mode. By changing the third element of B, changes also the third element of array A because they're pointing to the same memory location. V also supports slicing, so not much I can comment here. It's similar to other other languages that supports slicing. So here we can specify optionally the starting index and the end index. An additional thing in V is that it supports also the negative indexing, but this is possible by using the gate operator. So this means that the minus on the first index or the last index means that it will go minus X elements from the end. So here we have, let's say, A as a slicing from of array A from -2. This means that it will start from the beginning to the 6 minus 2 elements, which means element number 4. Right. V also supports fixed arrays, but there are two ways of declaring fixed arrays. One is by specifying the length on the square brackets, which is different from, which is not achieved by putting the length on as a parameter. That's a different thing. Another way, okay, so here we have an example, like line number 2, we specified an array of length 3 within the square brackets, not at the length as a parameter. And despite that we put A as a mutable, we only are able to change its elements of pre-allocated elements, but we are not able to extend it. As you can see on the line number 4, it will fail if we try to push one more element. Another way of declaring is by using exclamation mark at the end of the square brackets. As here we have an example on line number 5, we have an array of 4 elements and the exclamation mark. This is quite helpful when you have a function which has a fixed array as an argument. So when we call that function, if we simply give the array without exclamation mark, that will fail because V will notice that we are giving an unfixed array to a fixed array. The only way to tell V that this is a fixed array is by using the exclamation mark. So exclamation mark, back to the previous slide, not much needed in the declaration side, but much more on when we call the function. So we go to strings. Strings are simply declared by using single quote. V is also tolerant to double quotes as well. But if we use a formatter that V supports, it will replace all double quotes to single quotes. So strings basically are read-only arrays, which means that we will be able to get the length, as you can see on line number 5. And similarly to arrays, we are able to do the slicing. But the reason I'm saying it's a read-only means that despite that we made mutable on line number 3, the name 2, still we are not able to change the element, the 8th element of that array. But being mutable, we are able to reassign the string. So here are some built-in conversion functions of V for strings. So we can try to convert any string to integer. And here, as you can see, I just made a random text. Despite it contains a number inside, it will return 0. While when it comes to Boolean, it will return true only if it's the true word. Everything else will return as false. So it's also able to return hexadecimals, octals, and binaries from string to integer. Another good built-in function is bytes and bytes str. Bytes returns an array of bytes from a string, especially if you have to deal with serial communications. Sometimes we have to convert that on array of bytes and we get elements. Similarly, if you receive from serial communication, if you receive an array of bytes and you want to have that as a string, you can use the function byte str, which converts from a byte array to a string. Yeah, so another nice thing that V supports is string interpolation. When I'm saying nice thing, I mean the flexibility it provides, not because of interpolation. Interpolation in V is achieved simply by using the $sign and the variable name. But the reason I'm saying it's more flexible because we can, as you can see on line number 5, we can even call the members of the structure. Or at line number 9, we can do a Boolean or even math operation. Even we can do a V code within string interpolation. What I would recommend is to use the the curly brackets whenever you have to do a string interpolation. For example, if you add a dot, as you can see on line number 8, if we remove the square brackets and we have a dot, V will wait for its member. So by adding this curly brackets, we will save V from checking for the members. So here is how the interpolation formatting looks like. So right after the colon, we can specify the flag, optionally, of course, the flag, width, precision, and the type. So the flag, we can specify if it should be left aligned, zero padding, right aligned, or no alignment at all. The minimum width is specified, for example, if we have if we want to have a table style in terminal, we can specify the length of the column. Of course, the precision is used only on floating points. Here, similar to, I think, C, we have F, E, and G for floating points, and D, X, O, and B for integers. Yeah. So here is an example. We have the address given in hexadecimal. And as you can see on line number 3, right after the address, we specified that it should be zero padded, and the length, minimum length should be 10, and then the formatting as hexadecimal. So another big advantage of V is maps. So maps are built-in data types. Maps are declared again in two ways. One is by explicitly giving the data types, and it starts with the keyword map. Within the square brackets, we specify the data type of key, and right after the square brackets, we specify the data type of the value. Another way of the declaring maps is simply starting to add elements within the curly brackets, where we specify key and then column and the value. But the data type of key and value should remain the same on the elements below, otherwise it will fail. So here we have two examples when we have a map with key integer and the value in strings. The same one is achieved by simply specifying that implicitly on line number 9. So accessing and is similar to arrays arrays and strings. Another helper here in V is the OR operator. So if we try to access to a key which is not part of the element, we can use OR operator to help us return an error and handle that. Similar to arrays, we can use in operator to check if that element is part of the is part of the map. Another way of checking if keys is part of the map is by simply calling the keys function. For more documentation, you can check on the link below. So let's go through some basic of statements and expressions. So not much difference from C when it comes to if-else statements. The only difference is that by adding the condition that needs to evaluate it within the parentheses, it will fail because V considers that as unnecessary. The rest is the same. If-else statement supports also is operator. So is operator checks if the variable on the right side is part of that data type. So let me go through, because it seems like we do not have too much time. So unlike C, where we have switch and case statements, in V it uses similar to Rust, I think, which is match. And match can check the arguments same to select keys in C and execute statements. But in addition, it also supports returning a value from match. In addition to having case by case as it is in C, V supports also, for example, single value case, a range of cases, set of cases, and else is used for, let's say, a default. For loops, V does not support while do loop, but it supports only for loop. If you want to do while, like kind of forever loop, you can use simply for, but it also supports C-style loops, as you can see on the right side, line number 6. But the same one is achieved, as you can see on line number 3, because it supports ranges, and you can use in operator to check if n is in the range 0 to 10. The difference, shortly here, the difference between 2 dots and 3 dots at the match here is that 3 dots means that the AND element is inclusive, is included, while here it's excluded. So it will go from 0 to 9. Yeah, I went through in element shortly here, and as you can see on line number 8, in addition to elements, if you have a non-number arrays, you can get also the index. And similar to other variables, in for loops, the element is immutable. It is read-only, but by using mute operator, you can make it mutable, as you can see on line number 13. Similarly, instead of getting the index, you get the key if you use the in operator in for loops. V supports also a defer mechanism. So it also, like as you can see here, is really simple example. We would expect to have defer. We would expect to have start, defer, and end. But defer, it's call it right before the scope ends. So we have starting, end, and then we have defer. This helps, for example, if we have file handling code. So to make sure that the file will be closed, whatever we do on the scope, we use the defer mechanism, and we close the file here. So this ensures that a file will be closed by the end of the scope. So shortly to structs. Not much different from the C, except, from the look-wise. But as you can see here, it starts the member name and the data type. It also supports controlling the access and the visibility. So by here is a typical example on struct name. So A is private and immutable. By specifying the mute before the members, it will make following members mutable, but it will end until we have the next specifier. So we have on line number 12 we have pub, which makes D as a public, so it's visible from other modules, but immutable, just for read only. And line number 14 we have both pub and mute, which means both members public and mutable. Here is another more complex example. The struct player has a member's ID, player, icon name, score, and levels. As you may notice, the player is just a struct, which means that V supports anonymous structures. And another distinguishable part here is the few members, like ID, full name, and age, are tagged as required, which means that these members should be specified when we declare the array. Otherwise, V will fail. Another interesting part is that V supports putting the default value for structure. So despite that V does not support OOP, it supports methods for the structure. So the template is like this. When you start a function, you have within the parentheses you have the receiver function, which in this case is the structure point, and then you have the function name and the parentheses as with other functions. To be able to change the receiver structure, you should specify that as a mutable. As you can see on line 11 and 12, we call it the get point to return the point, and the set point, which because of its mutable, it will be able to set the values. Quite nice thing is that V supports also overloading methods. So instead of the function name, you can use the arithmetic or logic operators. Sorry, I'm going quickly. So V supports also embedded structures. If I have to take an analogy, it's similar to inheritance. So the structure pixel inherits not just members of the point structure, but also the methods of the point function. So whenever you declare the pixel structure or you call that function, it behaves like members of the point or members of the structure. Enumerators simply as you can start with enum, and you list the members. Here is an example how the enum is used on the match case. The reason I took this example is that whenever you have to call an enumerator and you have to use the values of the enumerator, you have to use the dot and call the enumerator. In V, enumerator supports also the assignment to a value. So it will start from 0, but once you assign one of the members at a certain value, the rest will continue to increase. Enumerator supports also methods similar to structures. Modules. So modules, it's quite similar to, I think, Go and Rust. So basically a module, all files within a folder, V considers as part of the same module. So, but if you have another folder, within that folder, root folder, all files within that folder becomes part of the module. For example, here we have submodule 1, which is .v, which is part of submodule, but module 1.v and the submodule itself is part of module 1. So if you can check on the right-hand side, we have imported module 1 and module 1.submodule 1. Let me go through a quick example. This is the piece of code that I'm working on a library for Vlang. It's TSP, which stands for Tiny Signal Processor. And we have tsp.v. This is a module. But within that module, we have an FRR folder and the FIR.v, which is a module itself, of course, but part of another module, which is the TSP. So here we have defined the code. I'm skipping this part. I'm going to the... So by the way, this is a module FIR, while on the code below, this is a module TSP. But if we go on the implementation part, the test.v, here we have imported TSP, and we have imported also tsp.fir, which means that FIR is submodule of the TSP. But if you call a function, which is, as you can see on line number 15, you don't need to have tsp.fir.new, but just simply fir, because we consider that as a module itself. But this helps to structurize in a hierarchical manner the modules. So generics. Okay.
We are out of time.
Looks like I have to stop. Okay. Yeah.
Okay, we are running out of time, so if you have any question, please reach out to Erdet. I think he'll be here, right?
Yeah,
After
sure.
for the conference. So thank you. Let's applaud him.
Yeah.